So, shall I start, sir?
Now we can start.
Thank you. Thank you, Ramesh, sir. Glad to know that you are one of the alumni of NIT Rourkela.
Yeah.
And thanks to Devasys, sir, for giving me this opportunity to give a talk on this. My audio is clear, sir?
Yes, yes. You're
Okay, so let me share my screen. So, can you see my screen?
not yet.
Okay. Actually, we are used to with Microsoft Teams and all. So, Meet is something I'm not very acquainted, but I think it's okay now.
Yes.
Okay. So, a very good morning to all of you. My topic is Internet of Things, its applications to the architecture. Internet of Things is not a new topic for today's era because starting from the school children till the researchers, they work on the various domains of IoT or the Internet of Things. So I'll just take a brief idea of what exactly IoT is, what are the different application domains of IoT, because you have one more speaker probably who will be talking on one of the major applications of IoT, that is smart city. So I'll be touching upon the different applications of IoT, why this has taken the front seat in the human life, why the importance of IoT is felt so much that now in every domain we think of using IoT for our day-to-day life. That's what is the major concern for or major focus for today's talk, as well as the architecture that helps to understand the concept of IoT and why the researchers are focusing on IoT and what are the different research domains or the research areas where the people can think of contributing in the area of Internet of Things. That's what is my topic today. So to start with, in the introduction of this IoT or the Internet of Things, we know that this word or the Internet of Things lies on two buzzwords. One is the internet, another is the things. Internet is very well known to us, all of us, because being the computer science, you are also in the computer science domain. So we all of us know what exactly is internet. So how internet is related to the things and what is internet and what is thing, how they are being combined together to give us a concept of IoT or Internet of Things, to we can understand from this. The internet meaning it is an application that need to support a diverse set of devices for data analysis and knowledge extraction. We know what data is. It is the information in some form or in some concern to a particular domain or particular area. Then we say it is a data. And when you analyze the data, we get some information from the data. May it be like your education system. Let's say the new education policy. It's an information. But when we go enter into the new education policy, we understand many data are there for a new education policy for the school children, for the higher education, the applications, the subjects. So you have different data or different related information in the same word NEP. So when we analyze all these data, we understand what exactly is new education system policy is. So data analysis is most important to understand the concept of something or to have the control over a domain or something. That is why data analysis is very, very important. And the knowledge extraction. What do you mean by knowledge extraction? Every information has a hidden knowledge. What we say is a metadata. So the data that you have, you infer the data or interpret the data to obtain the knowledge. or to extract the knowledge. That is what is the knowledge extraction. If I say the temperature of the city is something around 29 degree or 44 degree, the knowledge I extract from this is either it's too hot, or it's too humid, or it's too cold. So the knowledge, to obtain the knowledge, I need to analyze the data. I need to say that if the data, or if the temperature is above 30, it's hot. If it is below 10, it's chill. So this knowledge extraction needs the data to be interpreted or data to be informed. And that is what is possible if you have the internet. When we say sitting at Cuttack, if you say it's too much humid in Mumbai, meaning you have the data of Mumbai. And to have the data of Mumbai, you need to have the global data or the remote data, that is the internet data. So that is what is internet, that gives us to analyze the data, to extract the knowledge in the diversified domains or the diversified areas. And what the internet has, it has basically the different communication protocols. We know that internet is the network of networks, right? So if you consider a single network, and if you have multiple similar single networks, when they are connected to each other, then they are called as the internet. And when we say they are connected, how is it possible that they are connected? Meaning they are able to communicate with each other. One network is able to communicate with another network, and then they say that we are connected. To have the connection, the communication is mandatory. And to have the communication, we need to have some protocols. So if I communicate with one person who doesn't understand my language, then we cannot say this is an efficient communication, right? So if I talk a person who is coming from China, and I talk in my language and he talks in his language, then definitely it's not a communication. So what we should have some protocols. We have to follow the protocol to understand what someone is communicating. So every communication has got some protocols, and the protocol has to be followed in order to have the correct outcome of the communication. So when we say it is an internet having different networks and they are trying to communicate with each other, meaning they must follow certain protocols, certain rules, then only they can communicate, or the outcome can be an effective communication or effective output. And integration of the mobile devices, edge devices, and humans are the controllers of the internet. So when you talk about internet, usually I use my cell phone, my mobile phone. So that's a smart device that is integrating with another device, that is integrating with another network, and I communicate with each other, and then I say it is, one second. Sorry. So when we say they are communicating with each other, or the internet is available, meaning the internet uses the devices, and the devices are nothing but your mobile devices, or you can say any smart device or edge devices. Being the computer science students, I assume that you know what is an edge device, right? The router, the switch, the wireless access point, the Bluetooth devices, the devices that interface between a node and the network is the edge device. That is what is the edge devices, and humans as the controllers. So coming to this is all about your internet. And coming to the things, thing is nothing but your smart devices, the sensors, or the human beings. So what is a smart device? You know what is a smart device, right? Your handheld, your PDAs, your tablets, your handphones. But these are all the smart devices. But along with this, there are also the other smart devices, or what we say the smart sensors. When you say about smart, meaning it has some intelligence, it has the decision taking capability, then we say it is a smart one, right? So these, any device can be a thing if it has the capability of being a smart device. I can say this table as a thing if I embed a sensor onto it, if I embed a smart system onto it. Otherwise this table cannot be a smart device, or it cannot be called as a thing. So when we say about it's a thing, meaning it has the capability to communicate with other entities. That is what it say. Any device that is able to communicate with other entities, making it accessible at any time and anywhere, we say that is a thing. So whatever you are seeing on your laboratory, your desk, your chair, your door, your screen, your foot mat, anything can be a thing, provided it has a smart sensor. It has a sensor, or it has a device that can sense, that can communicate, that can process, that can store. Then we say that's what is a thing. So when we talk about this IoT or the Internet of Things, in that case, how you think the life could be? If you don't have internet, how a life could be? Imagine you wake up in the morning from the bed and your water heater is automatically switched on, and it's ready with the hot water for taking a bath. You don't have to go and switch on the geyser, and you don't have to wait for the water to get heated. It is already there automatically. You get up at 6 o'clock, it switched automatically switched on at 5:30, and by 6 it gives you the hot water. When you take bath, your microwave is ready with your food. So you come back from the bathroom by 7 o'clock and you get your food by 7:10. So that is automatically done. Who does it? It is the smart system. It is the Internet of Things. When you lock your door, when you want to go to the car parking, your car doors are automatically open and you just ride the car. That's what is the life. So your life becomes very easy if the things are being automatized, if your IoT is in your hand, or if the IoT is functioning. So when you are in the IoT ecosystem, you want everything to be automatized. You want everything to be in your fingertips. You start your cycle from the office and you want that my room or my home should be, the AC should be on in my home, the lights should be on in my home, the TV should be on in my home, the food should be ready on the table. You want that the fridge, your refrigerator should say that your vegetables is, I mean, it's almost empty, you need to go to the, it will automatically place an order to the store, and the store person will deliver the food to at your doorstep. So how these things are happening, right? These are all possible in today's era. So how it is possible? Because of the IoT, the Internet of Things, because the things are connected, because the things are able to sense, recognize, process, store, communicate, and deliver. That is why we say life in IoT ecosystem is much more comfortable and much more easier than earlier. So this is why the people wants to have the IoT in everybody's life. So that is what is the goal of the IoT. You want anything at any time, any device. There is no restriction. If I want to make this table as a thing, I'll just plug a sensor into it. This becomes a thing. Meaning it will process, it will communicate, it will start sensing, everything is possible. Anyone means irrespective of a human being, irrespective of anything, anyone can act as an, can be a part of the IoT. Any service, any business, any network, anywhere, any location. There is no restriction for the IoT ecosystem. Anyone can be a thing, anyone can communicate, anyone can process the data, anyone can get the benefits of the IoT. To make this, that is why we say we can answer the questions of why IoT, why you want to be a part of this Internet of Things, why the life is so comfortable in IoT or the Internet of Things. The reason, the answer to all this is you want to automate the things. You want to irrigate your lawn when sitting in the office. You want to cook your food when you are sitting in the office. You want to do your office job when you are at the home. So everything is automatized, and that is possible because of the help of the IoT. You want to control everything. As I said, you want to control the remote of your TV, you want to control the remote of your air conditioner, the refrigerator, your office, the farmhouse, everything. How is it possible? Because you have something in the remote location. That is what you say sensor. There is an actuator, there is a controller, and the remote is in your hand, or the program or the coding is in your hand. You give the order or the instruction, the things are automatically switched on or switched off. So you are controlling everything in your real life. That is what is possible because of the existence of the Internet of Things. And you want to receive more data. More data meaning Without data you don't stand anywhere, that we know, right? If I say there is, it's going to rain tomorrow, meaning this is just a statement I'm putting, and no one is going to believe me if I don't give the exact data, exact reference that it's going to rain tomorrow. So to have the accurate statement that it's going to rain tomorrow, I should have the proper data, I should have the proper prediction, I should have the proper information, the history of the data for last 5 days, how I'm predicting that, how I'm processing that, what is the exact temperature today, and why I'm saying it is going to rain tomorrow. I should have the reason for that. And that is possible when you have more and more data available with you. That is why this big data, the data analysis, everything has come into picture. And how the data is coming? This data is coming through the sensors. You find sensors everywhere, and these sensors collect the data, it senses the data, accumulating all the data, processing the data, then predicting the data or inferring the data, says some conclusion. It's going to rain tomorrow, it's going to be humid tomorrow. Everything is possible because we are processing the data. And these data comes from the sensors or the things of the IoT, and want to make the things faster. In today's day, when you don't want to sit on the table and have food, you want to have the fast food. The reason behind is you want to make the things faster. You don't want to travel in a cycle or a vehicle, you want to, or any train, you want to travel in a flight because you want to save the time. So human being, now being, the life has become so faster, and the moment you place an order or place a query, you want the result to come back to you. That is what is the real time system, what you are working today. You want to put a query, you want to book a ticket, you want to book a restaurant, you want to book a hotel, immediate, within no moment it should be available to you, because you want that the things should be faster. So to support your requirement, support the human requirement, the things have become now real time, things are becoming faster and faster. So who makes it faster? Is the processing, is the communication protocols, the communication between one end to the other end, the user end to the device end, the device end to the cloud to the edge. So all these communications are so faster that you get the result, you get the answer to your query in no moment. That is what is possible because of the technologies or because of the research that has taken place by the IoT. So to understand the whole concept of IoT, when you say IoT, it's the Internet of Things, and this must have some modules, some components, right? So what are the components? First component, as I say, is the things or the devices. We'll see more details about what the things are or what the devices are. So one component, major component, is the thing, meaning the devices that senses, that collects the data. Those are the things. Then there is another component that is called the gateway. I assume that you all of you know what a computer network is and what the gateway is. Gateway is the device that allows the data to enter or to go outside a domain in or a network. That's what is the gateway. So here, if the devices are there and they are collecting the data at this domain, then they pass the data to the rest of the world through this gateway. So what they do, they send the data to the gateway. The gateway then now makes some kind of packetization, some protocols, the MAC layer protocols, the network layer protocols, the routing of the data. Everything takes place by this gateway, and then the data goes out of this gateway to another module or another component called the cloud. Cloud is nothing but a virtual domain or virtual processing unit. It's a huge processing unit, huge storage, who collects the data. Why I'm saying it's virtual. We don't see where exactly cloud is, where the device is, where the storage is, but we do all the processing in the cloud. So that is also a component of your IoT. And your data that is collected through these devices or the sensors, now that reaches to the cloud, because cloud has got humongous amount of processing power and the storage. And now the processing takes place with the data that was being collected by the things. So once the data is processed or stored in the cloud, it goes for the analysis. Why? Because no, without any analysis, you cannot conclude a statement. If I say it's going to rain tomorrow, I have done some analysis on the data. Then only I'm saying it's going to rain tomorrow. Without analyzing the data, I cannot conclude that it's going to rain tomorrow. So that analysis, again, the artificial intelligence, your machine learning, deep learning, those all analysis, the different algorithms, they take part in this analytics part. So once they are processed, once they do the analysis of the data that is being collected, then we conclude with a statement saying this is going to happen, or this is not going to happen, or this is present, or this is absent, a concluding statement. And that concluding statement goes to the user as an user interface. So where we work as a common user as at the user interface side, we have a GUI, and we work on asking the question and asking the getting the response from that. So these are the different major modules, you can say, or major components who makes the IoT ecosystem. And each of this component itself is a big area of research, you can say, and it is different, all totally different subject as well. So that's what is the components of the IoT. Now coming to the characteristics of IoT, when I say it is Internet of Things, how you imagine it's an Internet of Things? What are the components? We understood what is internet, we understood what is thing, we understood how the different components of IoT are connected, how the data analysis takes place, how the storage takes place, so those things. Now to have an IoT ecosystem, or to have an IoT system, what are the characteristics, or what are the parameters we must focus on? So one of them is the connectivity. We'll study about the details of this. The next one is intelligence and identity, scalability, dynamic and self-adapting, architecture, and the safety. So these parameters are required or essential to have an IoT ecosystem. Without any of these parameters, we cannot say this is an IoT ecosystem, or it's not possible to build an IoT ecosystem as well. So coming to the first parameter or the first characteristics is connectivity. Connectivity means connecting two devices, two domains, or two networks, or two things, you can say. What is this connectivity? So one of the most important requirement of IoT infrastructure is the connectivity. If I say I am in the IoT device, you think of your cell phone. Suppose one day your network is gone, you are not connected to the rest of the world. Can you say you do exist in the world? You don't, right? Because you don't see much of the things, you don't get the information from the rest of the world. You say I'm disconnected, I'm totally out of the world, meaning you have no information. So if you have no information, you are not going to answer any query, you are not able to answer any query, you are not able to predict anything, you are not able to read anything, you are not able to know anything. So without connectivity, we cannot think of the IoT existence. So one of this major parameter, that's why we say connectivity, meaning connecting one thing to another thing. So how that is possible, whether the internet does that, whether the Bluetooth does that, whether the Wi-Fi does that, whether the Zigbee does that, we don't know. But what we know is we need the connection. If I say it is the Internet of Things, because this buzzword internet is there, the connectivity has to be there. And things should be connected to IoT infrastructure. What is IoT infrastructure? Is wireless connection. My cell phone is connected to the IoT. I don't know that because I don't see what is beyond my cell phone. But what I know, I'm connected to the rest of the world. And that is what is the connectivity. So anything that you assume is a part of the IoT has to be connected to the rest of the infrastructures. What are the IoT infrastructures? That we'll study. And then is the connection should be guaranteed anytime, anywhere, with anyone. Without this, we cannot say we are part of the IoT. 24/7, the connectivity has to be there so that we say we are a part of this IoT, or we are working on the IoT, or my device is one of the component of the IoT. No connectivity, no IoT. It's not possible at all. Next is the intelligence and identity. As we know, intelligence. What is intelligence? We have some intelligence, human intelligence, right? Why we say we have some intelligence? Because we are able to perceive something, we are able to understand something, we are able to communicate, we are able to, I'm sorry, we are able to see something, that is the sensing. We are able to store something, that is in our memory. We are able to communicate something because we speak. We are able to think something because we are processing. So we say we have some intelligence. So replicating our brain or a human being to another system, meaning the system should have some intelligence. The extraction of knowledge from the generated data is more important. That is what it says the intelligence is. A device, I can say, let's say, your smart device. When you don't have space in the memory, it gives a message. There is no space. Your camera sometimes doesn't switch on because there is no space. How it is possible? Because your smartphone is aware that there is no space available in your device and I cannot store any more data. So it doesn't start with the camera or it doesn't start with any processing. That is the intelligence of the smart device or your smartphone. So how this intelligence had come? Who put this intelligence into it? The code, the IoT coding or the IoT input that you are giving, making the device or making the thing a smart thing. So that's what it says. For an example, the sensor generated data will be useful only when it is interpreted properly. Each IoT device has an unique identity. That's okay. So let's say I put a temperature sensor in this room, right? The temperature sensor is continuously reading the data. Sometimes 29 degrees, sometimes 29.1, 0.2, 0.3, 0.4, 0.5. So that way it's constantly, it is throughout the day, it is reading the data and giving me a data, complete data set, that the 24 hours data of this room is 29 something, right? So how I extract the knowledge from that? Now what I'll do, I'll analyze the data. Whatever reading that sensor is given me, I'll analyze it and I'll say that the average room temperature of this room is 29 degree. And if I say that my intelligence or my device intelligence says if it is 29, the temperature is moderate. It's not too hot, it's not too cold, but it's moderate. So to say this word, it is moderate. It is not too hot. It's not too cold. This knowledge I extracted because I have the data for a longer span of time. And who gave me the data is the temperature sensor I put in this house. So the intelligence comes with the data. The data comes from the sensor. The sensor is nothing but a thing of the IoT. So this is how your world goes. Starting from the tiny sensor who gives the reading is analyzed, the knowledge is extracted, and then you say something that this is what is happening. And we say the whole thing is the IoT, the Internet of the Things. And now, identity or identification. Suppose I have 5 temperature sensors in this room. So which sensor gives me the reading at what time? How can I know that? Like 5 students, you're sitting in one classroom and you have the smart devices. You are answering to the quiz or answering to the queries. Your teacher is asking you the query and you are answering the query. So how does the teacher know that which student has answered me this? You have an identification, right? Your roll number is the identification. So from getting the answer from a particular roll number, the teacher understands that this student has answered my query, meaning you have an identification. The same thing happens with the things. When multiple sensors give the reading, they must be identified. Otherwise, we cannot say my east corner sensor gives this reading, my west corner sensor gives that reading, or what is the exactly reading from any random sensor. You have studied computer networks probably. You know that any device that communicates has should have an IP address. What is that address? Is nothing but your identity. So when you are communicating, you should have an identity. When we are communicating now, in every picture, our name or our designation or our roll number, everything has been mentioned in the this meet, Google Meet, to identify who is talking, who is listening, who is asking, or whoever, whatever who is doing. So every entity in a communication protocol has to be identified so that it can be efficiently worked upon, efficiently designed. That's what is your intelligence and the identity and scalability. The probably. Meaning, if you are able to recognize the forest fire for a 1 kilometer radius forest, and if you are able to recognize the forest occurrence of forest fire for a 100 kilometers forest, so whether it is a 100 sensor forest or it's a million sensor forest, doesn't matter. The IoT should be able to have a larger system. That is what we say scalability. Scalable meaning the number is high, very high. Let's say a DOS field, you have the DOS sensors are being deployed. Any intruder that comes into the war area, the borders are so huge areas of borders, but still then the country borders, right? So they are able to understand where the intruder or the enemy enters into this. So how many sensors you can think of putting into this war area? Millions. So in that case, you cannot think of some 100 sensors or some 500 sensors working on that. One second, student, just 1 second. Pore didi. So that's what is the scalability. When we say about like an agricultural field, the huge agricultural lands, now the sensors are being deployed through the helicopters, because it's not possible to deploy the sensors on the large areas of agricultural fields. So what we do at that time, deploying those sensors, meaning we deploy from the air, or it is being deployed through a helicopter. So scalability says when you think of IoT, don't think in a miniaturized size. It has to be large, very, very large in size. So you think of a small agricultural land or your lawn in your farmhouse, or you think of a huge agricultural land in the country or in outs, I mean somewhere. So that is what is the scalability of the networks, and the IoT supports the scalability. So any IoT setup should be capable of handling the massive growth in the number, and the data generated is also enormous. If I generate 5 KB of data from 5 sensors, I should be able to, and I process that 5 KB of data, I should be able to generate 5 gigabyte of data from 500 millions of sensors. I should be able to process that as well. Then I say I remain in the IoT system. I work with the smaller size, I work with the moderate size, I work with the huge size of sensors and the data that is being generated from the sensors. That is what is the scalability. Then is dynamic and self-adaptive. Dynamic, you all of you know, right? IoT devices should be dynamically adapt themselves to the changing context of scenarios. I deploy a sensor in the war field somehow, and I need to change, or I see that the sensor battery has gone down, right? So should I go to the war field again and change the sensor there? Is that possible? No, right? So, and if it is not possible, then the sensor is gone, it's dead. If the sensor is dead, that means I'm disconnected from that locality, isn't it? That is what is called the major challenge in the IoT field. What we do when we deploy a sensor in any area, maybe any difficult terrain or any rocky area, the sensors should be self-adapting. Self-adapting meaning, if you have studied sensor networks, usually the sensors, they work in different cycles: awake cycle, sleep cycle, idle cycle. Sometimes it works, sometimes it goes to sleep mode, sometimes it remains in the idle mode. So they remain in different cycles so that they save the battery, save the energy power, because sensors are tiny sensors, right? They're very tiny, and when they're tiny, how they operate with a battery power. And when they operate with battery power, such a tiny sensor, how big battery you can embed into this? Is definitely very small, tiny battery. And if the battery is also tiny, how much capacity the battery can be? Very low. And if it is, sometimes if you are putting the sensor in your house, it is possible that once the battery is down, you can right. But if the sensor is deployed in a war field, if the sensor is deployed in mid of the ocean, if the sensor is deployed in the human brain, can you take it out and change the or replace the battery? Not possible, right? So in that case, how the sensor will work? You make them self-adapting. Either they save their battery in such a way that they last long, or the lifespan is very, very high. Or the other way you can do is, if one sensor is dead, the immediate next sensor should take up the role of that sensor. He will find the connectivity among the neighborhood and then he will start working on that. That is what is called dynamism and self-adapting in a sensor network. Because one of the major domain of IoT is the sensor network. If the sensors are functioning properly, you get the data properly. If you get the data properly, you analyze the data properly. And if you analyze the data properly, you give the outcome properly. So they are all related. And the basic component or building block of IoT is the sensors. So make these sensors dynamic and self-adapting in terms of their lifetime or in terms of their battery power. So for an example, it says a camera working in an IoT environment should be adaptable to work in different conditions, different intensity of light. Your mobile phones, smartphones are like this, right? The intensity of light changes with the surrounding light. How is it possible? Because they are self-adapting. They understand the background light, they sense the background light or the light surrounding them, and accordingly they change their intensity. And you click a picture, your selfie, and all those things what you do. So that is what is the dynamism and self-adapting of the sensors. And then is the architecture, which we will be studying in details after some time. The IoT architecture cannot be homogeneous in nature. The reason behind is, when I say thing, I say a smartphone is a thing. It's a electronics device. I say this table is a thing. It's a absolutely a non-living thing, or it's absolutely dead thing. I say human being is a thing. It's a living thing. Meaning, when I say thing, it can be a living, it can be non-living, it can be an object, it can be anything in this world. Anyone can be a thing. So the architecture, the underlying architecture for all these things cannot be homogeneous, cannot be same. That is what it says. When we talk about the architecture of IoT, it has to be heterogeneous. We cannot think of any homogeneous nature. How they are adapting, why they are heterogeneous, how they function in heterogeneity, that we'll see. And it should be hybrid, supporting the different manufacturers' product to function in the IoT network. If my phone is Samsung phone, your phone is Apple phone, somebody phone is any other phone, all are working together, right? They are communicating with each other, right? So how is it possible? Because they are adaptive. The manufacturers are designing the things so that they function in the same environment. If I use this table to communicate with your table in the laboratory, that is also possible. But my table is, let's say it's a Godrej table, your table is something like your any other table like. So in that case, how they function? They are different. The manufacturers are different. The design is different. The materials used are different. The total everything is different. But still they communicate. Still they work together. Still they function to give a common goal of communication and giving the output proper. That is what is the why we study the architecture of IoT. It's a huge area, but we'll try to make them compact and study. You should at least know basics of architecture, why this IoT architecture is required to understand. And safety is, of course, without safety you cannot think of. So there is a threat of sensitive personal details of any user getting compromised when all the devices are connected to the internet. You know it very well. The cyber security, why that is there. Your phone, your account, your Facebook account, your Gmail account, your bank account, everything sometimes get compromised. The reason behind it has been hacked. Someone is trying to, or any intruder is trying to get the data. So it is always a basic requirement for any cyber system to have proper safety. And when you talk about Internet of Things, everything is connected to the internet. So how can you compromise, or how can you ignore the part of safety? Not possible, right? So safety is another feature. That's what we say IoT security. It's a huge area. How the security is maintained for IoT environment when everything is connected to the internet. You cannot compromise, or you cannot ignore that my device should not be connected to the internet. Not possible, because if you want to remain in IoT ecosystem, the things have to be connected to the internet. And if it has to be connected to the internet, then meaning the security can be compromised. So how the firewall works, how the security algorithms work, how the encryption, decryption work, how the authenticity work, how the your authorization work, everything has to be taken care of so that the safety is maintained in the IoT. And as you know, the safety can be this could cause a loss to the user, and the equipment safety is also critical. Starting from the equipment safety, starting from the data safety, starting from the things safety, that is starting from the user safety, everything has to be taken care of when we talk about the IoT security, safety, and security. So when we understand all these features or the characteristics of IoT now, we can modularize different things now. So what we say, the different IoT ecosystem domains. Now you see, here are the some of the device manufacturers. Manufacturers meaning these are the IoT things. You can see the cameras, you can see the industries, you can see the transportation system, you can see the farming, you can see the mic, you can see your any garbage bin, you can see a lock, you can see a house, you can see anything you see in the world can be a thing or it's a device. And the device has to be embedded with a sensor to say that this is a thing. So those are the device manufacturers. Now, once you have these devices, what the devices do? The devices with a sensor, they sense the data, right? They sense the data, they collect the data, and then they have to disseminate the data. They have to deliver the data to a different world, maybe a gateway, maybe to a server, maybe to a cloud. Somewhere they will give. So who does that? Who gives the data? Who helps the things to deliver the data? Those are the service providers. You know what are the service providers, right? What is the role of a service provider? Jio is a service provider. BSNL is a service provider for our telephone communication or your GSM devices or the smart devices. But when you talk about this things to communicate in the IoT environment, there are also several service providers. They can be the Bluetooth, they can be the Zigbee, they can be the LoRa, they can be the Wi-Fi, they can be anything. So these are the different, the symbols. These are the Wi-Fi symbols. There are some Bluetooth symbols. So many of these supporting technologies, you can say, they are the service providers who help the data that comes from the device to be communicated in a different environment. And now, what are the industries or the enterprises that take the benefit of this IoT? You see here the naval system, the transportation system, home automation, the smart system, the industries, the hospitals, the education system, the manufacturing system. They are all the enterprises, those who take the help of the IoT or those who utilize IoT in their day-to-day life. When we are conducting this webinar, this is possible because we have something called the IoT system. We have a sensor, we have the camera that you are seeing me, that is a sensor, right? It is recognizing me, it is taking my picture and sending to you. That is a smart system, that is a thing. I can see you, when I hear the mic that is sensing my voice and communicating to you, that is also part of the IoT. So everything is now connected, or everything is now the part of the IoT, you can say. And finally, you have the application developers. Who are the application developers? It is you, the person, the people who does the coding, who does the data storing, who does the database management, who does the data structure, who does the memory, your analysis, the machine learning, the prediction algorithms, support vector system, random forest, any algorithm you put, you are the application developers. You do the process the data, you analyze the data that is being collected, that is being given to you through the service providers, and finally you conclude something, and whatever is concluded is used by these enterprises. So if you classify the domains, who are the actual domains who are working on this IoT ecosystem, you find these are the major group of domains, those who are working for this IoT. And to have the elaborate of this one, now when you talk about the devices, as I said, the devices are nothing but, you can see these devices, right? These are the devices. You can see anything. Can you think of this? Can be this stetho, this a solar panel, this any watch, any the speaker, the mic, the phone, the your clock, the car, everything. They are all the things, and they do the work. So these are the devices with the sensing systems. They have the sensors embedded into this, and they work as a thing. Now, as I said, the service providers, here these service providers, they give the connectivity. So how they give the connectivity? By the Wi-Fi, your GPRS, your GSM module, your Bluetooth, your Zigbee, any kind of connectivity they are given by through this devices, and this data that is being sensed through the connectivity, it comes to the cloud. Why it is coming to the cloud? Because cloud, we consider that the cloud is the storage of the data that is being collected through the sensors. So when it comes to the cloud, you see these are all the data. Those are being stored here. The memory is the storage system. And now from this cloud, it goes to an analytics part. Here in the analytics, it does the analysis of the data by using the supercomputers, by using the small computers, by using your mobile handset, by using your small devices. But some processing is being taken care of. And some processing, this analysis says what is the outcome of the data that was being sensed by these devices. And now, after the analysis, a conclusion comes, an output comes from the data, and that goes to the end user. And who are the end users? It can be any human being, or even it can be system as well. It can be a computer, it can be any smart device, can be also an end user. So this is how the different sections or different parts of the IoT takes place. Sensing, then communicating, then processing, then or the storing, then analyzing, and then finally delivering to the data. Consider a healthcare system here now. In the healthcare system, the devices can be your biosensors, your temperature sensor, your SpO2 sensor, your blood glucose sensor, your EEG sensor, your ECG sensor. Multiple sensors are there, and these sensors, they communicate through your, you have the smartphone. Through the smartphone, they communicate to the cloud. Then after this cloud, it is being analyzed, saying that whether the patient is having a high fever or not, it is having its sugar or not, he is having some sleep apnea or anything. So that is the conclusion. After this analysis, we conclude that the patient has got this parameter, this disease, and then it is being intimated to the family or the doctor or the patient himself, something. That is how is the different parts of the IoT goes. So to conclude this, we say now, thing meaning thing is nothing but your hardware, the software, and the service. Hardware is the sensors. Software is the protocol that works on this sensor, and the service is what you get and what you exchange for that. That's what is the thing it is. So examples of things are temperature sensor, pressure sensor, human beings, server, vehicles, shoes, wearables, pacemaker, food quality measuring. Anything you name, that can be a thing in the IoT system. So here are some of the examples of the things that you can see. You can see anything in this world existing can be a thing of the Internet of Things or IoT. So now when you talk more about this IoT, we can broadly classify the IoT into two kinds. One is the consumer IoT, which are the wearables and the smart home devices that are being used. Another is the enterprise IoT. And this is the IoT in improving an organization's existing system and the process. Usually this enterprise IoT is also a part of the industrial IoT. Now the IIoT has come, that is industrial IoT. So one we classify is the consumer IoT, another is the industrial IoT. So what we'll be talking about is mostly on the consumer IoT. And why the IoT is so powerful? Because it can do any of these following things: increasing the efficiency, improving the health or safety, creating better experiences. This is why we have understood by now why this IoT is there. More output with the same input, and same output with a less input, then only we say it's an efficient. Obviously, yes, right? So when you have been give the all the students given the same questions in an exam, why someone tops in the exam, why someone not? The reason behind is he is an efficient student. Who tops in the class is an efficient student. How is it possible? He has been given the 3 hours time, the other student was also given the 3 hours time. So within that 3 hours, he could give the maximum output through writing, through diagrams, through something. But the other guy who could not give, we say he's not that efficient. So efficiency meaning you have the same platform, you have the same parameters, same constraints, same challenges, but the who gives more output becomes the efficient one. And here in case this term, when you say input, what is the input? It could be the time, money, energy, any resources. And output could be Output could be like manufacturing efficiency, asset tracking, energy efficiency, agricultural efficiency, inventory management. There is a long list of that. We are not going to read about all those output of the things. So leave all this thing. I'll just quickly go to the, yeah, I'll quickly go to the applications, IoT applications. What this says, one is the smart home. Now everyone is having an Alexa in home. Everyone is having a, I mean, the Alexa in your car. Everything is there. So that makes your home smarter, right? Alexa, switch on the fan. Alexa, switch up the light. Alexa, play this song. So how this is possible? Because this gives you the, you make him the assistant. You make him the electronic assistant, e-assistant. So your home becomes a smart home. Smart wearables. Everyone is wearing a smartwatch now. Gives you the reading about how many steps you have covered, what is your EEG, what is your pulse reading, what was your sleep analysis. Everything is being given to you because you have the smart wearables. They analyze the data. They analyze the data. They give you the reading, asking you or indicating that you have a good sleep last night, or you have covered, I mean, your 8,000 steps today. You have covered this. You have burned so much of calories today. So this is possible because you have the smart wearables. Another is the very common thing, smart city. So smart city, your environmental monitor, the city. When you talk about city, again the city has got multiple parameters, multiple domains you can say. So when you say it's the environmental monitoring, either it's the waste management, it's traffic monitoring, it's healthcare, it's a smart grid, it's a smart retail, or we can say also smart weather forecasting. That is of course the, and that comes under the environmental monitoring. So when everything becomes smart in a city, we say that is a smart city. Everything is smart. Even there should be another smart education. So those everything, when everything comes as a smart component, we say that is a smart city. And smart parking. Nowadays we are having the smart parking system, right? So in India also, you can see when you start from home, you can check in the parking area whether there is a parking lot available for you or not. And if you want to book a parking lot, you can book it here. Or if you see that before entering the parking, if you see that there is no empty space in the parking, you don't go there, you find somewhere else. So that is also there, smart parking. Smart agriculture, precision agriculture, everybody knows that. I sit at my home, I take the reading from my lawn or from my garden, that my soil moisture sensor says that the soil is now dry, it needs to be moisturized, it needs to be irrigated. So what I do, I just switch on one, I click one button in my cell phone, and automatically my pump is on and the whole of the garden is irrigated, watering of the plant. That is possible. So that's your smart gardening. Smart agriculture is in a bigger scale. You have the sensor, you have the controller, you have the actuator, you have everything in your fingertip. Smart farming, that is also there. Disaster management, I think it's in Odisha, disaster management has taken a very I mean front seat now. We understand when the tsunami is coming, or when the flood is coming, when the cyclone is coming, everything is now properly analyzed, and we are able to do that. And another is, as I said, for the forest fire detection, that is also possible. River floods is possible. Everything is possible because we have the IoT system with us. So this is an example of your smart home. You can see here, this home having some, your remote sensors are there, your window sensor is here, your foot mat sensor is here, your door sensor is here, your security alarm system is there. Sorry, your HVAC control sensor is there, your temperature monitoring is there, light control is there. Everything is being automatized. You have sensors for everything. Your fire sensor, smoke sensor, temperature sensor, humid sensor, every sensor in your, doorstep door sensor, your foot mat sensor. They talk about what exactly is happening in your home. You have the cameras, that is also a sensor that says what is happening in your home. Any movement in your home will detect that, say that yes, somebody is there in your home. So these are all the different sensors. Those have been put in the home, saying that this is a smart sensor. You see, all these things are being controlled by this Alexa. Your phone, your phrase, your audio system, your video system, everything is being controlled by one Alexa, because that is a smart sensor. And here are the smart wearables. I told about the smart watch, but there are also smart wearables like globes, like there's a Tesla autopilot, they use this Intel globes. You have the helmets, you have the jackets, everything. Now you have the smart glass also. Those are also the smart wearables. Now starting from watch to the jacket, from the helmet to the gloves, everything is smart. They have this. When I talk about, when I say smart, meaning they have the intelligence, they are capable of sensing, they are capable of communicating, they are capable of getting the data from the others also. So those are the smart wearables. These are some of the smart wearables that you already know. So, and as I said, the smart city components, the smart manufacturing, smart government, your mobility Wi-Fi systems, the digital citizens, the open data, smart health, smart farming, smart building, smart grid, and smart transportation. Everything is being smart or intelligent. Then we say it's the smart city components, or it's one of the IoT applications. The same thing again here. You have the healthcare, everything. This COVID treatment was also part of this smart city concept, you can say. So it was also one of the IoT concept, you can say. And here is also some more about the smart city environmental monitoring. When I talk about environment monitoring, we read about the temperature, humidity, the lakes and dust, the vibration, noise, smoke, the real-time alert, the dashboard and report. Everything are being connected to the environmental monitoring, and then they get communicated to the end user, and they say check for the different kind of things. That's what is the smart city environmental and monitoring. Waste management, the waste vehicle, the garbage collection vehicle finds a proper route to the destination. If you say a vehicle that is coming from one area of Cuttack, and it finds that there is a blockage in the road, there is a traffic in the road, it follows a different path to go there. That is a smart transportation. The other way, if I say the garbage bin in B.O.S.E, nearby B.O.S.E is filled with the garbage, and another garbage bin in near this, the Badambadi area, if that is empty, then the vehicle should not go to the empty trash area. Rather, it should route to the filled garbage area to collect the garbage first, so that to make the garbage bin empty. So that is also possible in the smart waste management. So how does this possible? How a waste bin or a garbage bin near Bose Cuttack is identified as the dustbin filled with the garbage? How is it possible? Because there is a sensor attached to the garbage bin, and the sensor detects when the garbage comes up to that level, saying that now it is going to be filled. So it has to be emptied fast. Automatically it indicates, it sends a message to the garbage collection vehicles that this bin is going to be filled fast, so please clear this fast before you go to any other area. That is what is the smart waste management system in the smart city. So here are also the other components or other things in the smart management. Just 1 second, students. So these are the some of the smart waste management systems here. And then the smart city or the traffic monitoring, this is also another concept of the IoT applications, you can say. Traffic monitoring, you know that, right? Sometimes you get the message also, this, the GPS, when you say about the GPS, that's also, it's a kind of traffic monitoring. You said that this is you have 3 routes. One route said you get longer route in this, you get the jam in this route, you get the traffic in this route, or this route is clean and clear and empty. So these are possible because it senses the data, it gets the data, the satellite data here, and the data in it predicts, and it says that you follow this route. And the same thing is going without, not with the satellite, but with the sensors. In the roadside sensors or the RSUs, the roadside units, they give you the data saying that don't follow this path, follow the other path, there is a jam ahead. After 500 meters you get a jam, so don't go in this route, you change the route. So that is what is the traffic monitoring in the smart city system. Healthcare is very, very common, you know that. E-healthcare, M-healthcare, smart healthcare, remote healthcare, these are, it's like smart healthcare is like, it's like booming like anything now. Everyone is working for this remote. The experts are in one city, the patient is in another city, they connect the data, they get the patient data, they analyze it, they say that yes, you are suffering from this disease, and then they prescribe the medicine. That is called e-prescription again, and or e-health record, EHR. So all the data for a particular patient is being recorded. Maybe it varies from hospital to hospital, but now again the government is working that every person should have in data health record, electronic health record. Every record data has to be maintained there and to be stored there, so that there cannot be any manipulation, there cannot be any controversy on the health data or the private data of any patient. That is what is the healthcare thing. And coming to this, IoT is the backbone of the smart healthcare. You see here, there are the emergency response, there are the smart hospital, the nurse, the doctor, the technician, the on-body sensors, the smart gadgets, the smart home, the robots. They work together to form the smart healthcare system. Maybe it is for a smart city or may not be for a smart city, but e-healthcare or the smart healthcare is always there. And smart grid is by how you generate the electricity, how you consume the electricity, how the different units, the residents, the your what you say, the industries, how they consume this. Those are the things. And smart cities, smart retails, now this has also come into picture or come into play now. A device, a particular rack, when it is consumed with the devices or the components, they say that this is over. Now you should have more components or more product to be kept in the shelf. So those are called the smart retailing or the smart system. Your big bazaars, I mean the big, not big bazaar exactly, but the big stores or the malls, they are having this smart retailing system now. So this, for the smart retailing system, you have something like called the item master. There is just transfer of the stock, then the sales management, then they say that see the physical stock, then they go for the purchase of management and the order of the management, and again it comes back to the store, so that your components or the content of the stores, they remain intact. The consumer or the user doesn't face any difficulty in this. This is another is the smart parking, how they do the parking so that the traffic cop, they can have an easier access into life. And the smart parking, and this is a smart agriculture. As I said, in the smart agriculture, you have usually mostly we are using the tractors, and these tractors are also now connected to with the Wi-Fi connection, or you have the drones, or you have the helicopters even. And the drones are used to deploy the smart dust or the dust sensors onto the agricultural field. That is how it functions. This is smart farming, fish farming, your normal farming is there. So disaster management, as I said. So these are some of the applications already you have seen, and these are the details of the all these things that of the IoT applications. So now what we understood is what exactly IoT is, why it is required, why you understand to have the IoT, why, what are the components of the IoT, what are the domains of the IoT, and what are the applications of the IoT. So now we have a thorough idea of exactly what is internet, what is thing, how they are connected, how they do the things. Now we'll just know a little bit about this architecture. Why I say this, because if you don't know about IoT architecture, you cannot imagine how the things are happening. So in the architecture, you'll see there are 4 layers, or what we say 4-stage architecture. There are also more detailed architecture, 5 layers, 6 layers, 7-layer architecture. But to make it very simple, we'll go for the 4-layer architecture. The first layer is the sensing layer. As I said, sensing layer is the basic building block of the IoT architecture. Here in this layer, what are the things? The things are the physical objects, the sensors, and the actuators. The sensors, the sense the data. The data can be temperature, humid, environmental data, health data, your farming data, forest fire data, ocean data, air data, any data, health data or human being data. So everything are being, they are taken care of by a layer called the sensing layer. And the role of the sensing layer is the data gathering or the data sensing or data accumulation. That is what is the sensing layer. The once the sensing layer is ready with the data, it goes to the next layer. The next layer is nothing but your network layer. In the network layer, who are the components? The gateways, the network technologies like your Bluetooth, your Zigbee, your LoRaWAN, your LoRaMAN or LoRa, then your Wi-Fi, then your GPRS. All these technologies you have studied till now, they come under the network layer. And what is the function of the network layer? Is the data transmission. So the data that is being gathered in the sensing layer has to be transmitted to the outer world, or this outer world can be a server, can be a cloud. And to be communicated to that layer, we need the network layer who communicates the data, who transmits the data from this sensing layer to the upper layer. So what is the upper layer now? Is the data processing layer. Here the data is being processed. Processed means data is being cleaned first, because when the data is there, a lot of noise will also come with the data. So lot of redundant data will be there, duplicate data will be there. So the data has to be cleaned first. The redundant data has to be eliminated, the noise has to be eliminated, unrequired data has to be eliminated. Then the actual data will be analyzed. So that is what is called the data processing layer, and the job or the function of the data processing layer is to process the information. So the data through this network layer comes to the processing layer. In the processing layer, it is being processed. Here in the processing, there are n number of algorithms can be taken care of, n number of tools can be used to process the data, to predict the data. And once the data is being processed, now it has to go to the application layer. And who is in the application layer? Is the end user. We, the people, are in the application layer. So here is the smart application and management. We have the smart systems, smartphones, and those phones help us to see the data, to get the data, or to get the information. So application, the function of this application layer is to get the smart applications. You have a huge application stores in your mobile phones, right? So you download any app, you get all the information related to that. How is it possible? Because already the informations are being processed at one end, and once you download the app or you install the app, automatically you get the information related to that domain. So that is what is happening in the application layer. So it's to understand it very clearly. Nothing, there is a sensing layer, sense the data. There is a communicating layer, communicates the data. There is a processing layer, process the data. There is an application layer to see the outcome of the data. The whole thing contains is your IoT. That is what is the architecture. That is what we can see to understand. But to go a little bit more technical about this, we now consider this architecture as a 7-layer architecture. The first layer remains as it is, the sensing layer, physical layer or the sensing layer. If you have studied computer networks or data communication, you must have studied the OSI model, right? OSI model has got 7 layers, starting from the physical layer till the application layer. Now you can map this architecture with your OSI model. So this is the physical or the sensor layer where the sensing of the data takes place. That is what we consider from the bottom up approach. This is just layer 1. Then it goes to the next layer. What is the next layer? Processing and control action layer. Here the data is being, when I talk about this processing layer, it is being pre-processed. How the data is pre-processed itself. That is the processing layer. Then to upper layer, it goes to the hardware interface layer, because in the hardware interface layer, now it will leave the sensor, it will go to somewhere else. So the next is the RF layer. RF layer, radio frequency layer. This helps the data to be communicated from one end to the other end. And then again, the session or the message layer. Session layer, if you remember in the OSI model, this is also helps in getting or messaging different units. And then user experience layer and the application layer. The number of layers remains same, but only thing the title changes or the caption changes, but the function remains nearer less same as the OSI model layers. So as I said, the physical layer, the layer is concerned about the physical components. This is responsible for the data collection. Choosing the appropriate sensor is the major challenge, and as many sensors are available, they can do the same task but at a different cost. For a temperature sensor, I can buy a temperature sensor at 50 rupees. I can buy a temperature sensor at 500 rupees. So it is up to me which accurate sensor I want to buy for which application. So that is what is the job of the sensing layer and the choosing the sensor. So these are some of the type of sensors that is already been given. So you can think of any of this sensor and for the sensing layer. Then comes the processing layer. This layer comprises of core components like microcontrollers and the processor. Here the pre-processing takes place. So you know the microcontrollers if you have studied the microprocessors, right? It has the processing, it has the storage, it has the read and input output, everything. It's like a small tiny computer. So unless you have a computing device, it cannot do the processing, right? So that is what is being done in the processing. The data is received by the microcontrollers from the sensors, and some of these microcontrollers. One second, guys. One second. Hello. I'm in a class. Can I talk to you after 5 minutes? So some of the microcontrollers are the Arduino, you know the devices, right? Arduino devices, Raspberry Pi, the Node MCU. These are all the different microcontrollers. They function on this. And to have this hardware or the microcontrollers, you also need the operating system. Your operating systems are your Apple operating system, the Android, the Linux, all these operating systems. So everything is being designed, or they are put in one of the layer called the processing layer or the control action layer. And here are some of the examples of them: the Raspberry Pi, the Arduino, the OS, that. So these are the devices, those are used in the second layer. Coming to the third layer, here usually actually the interface, the interface, the connecting modules, the connecting devices. This layer includes the components or the interfaces used for communication, such as the RS-232. These are the cables and the connectors, right? They connect between the sensing layer to the device layer, or to the gateway layer, you can say. These interfaces are used for serial and parallel communication at various baud rates. If you have studied the data communication, you know what is a bit rate, you know what is a baud rate. Synchronous communication, asynchronous communication. These are all basically totally on the computer networks or the data communication part of the, because as I said, IoT is nothing but it is a it has it under this umbrella of IoT. Your data communication comes into picture, your computer networks comes into picture, your WS and wireless sensor networks comes into picture, your communication technologies comes into picture. So all of them, they play a major role to build up the IoT umbrella, I can say. And for this hardware interface layer, you have the components for the communications, like the serial component interface, the parallel interface. So these are the devices, how you manage with a router, how you manage with a switch, how you manage with a wireless access point. All those things, they come into the picture for the hardware interface layer. And as I said, the RF layer, the radio frequency layer, this layer houses the RF technologies based on the short range and long range communication. And the common indoor RF or wireless technologies like the Wi-Fi, the Bluetooth, the Zigbee, the NFC. The NFC is the near far communication. And these are some of the technologies that are being used for communicating the data from one end to the other end, or for one thing to the other thing, or one network to the other network. So these are technologies, you can say. Here are the some of the symbols for these technologies or the RF layers. And as I said, the session layer, this consists of basically the protocols. If you remember the transport layer protocol in computer networks in the TCP/IP model, that contains some protocols, right, or the application layer protocols. So here also in the session or message layer, this deals with various messaging protocols like MQTT, CoAP, then HTTP, FTP. So these are the different protocols, and these protocols have got different purposes. Like MQTT protocol, it goes with a publishing and subscribing kind of thing. HTTP, right, hypertext transfer protocol. So in the conventional network, if it is HTTP, if it is IoT network, it becomes MQTT. So MQTT has now taken over the HTTP. So when you talk about MQTT, you must know about the HTTP protocol. And these are the protocols, all the protocols, basically all these protocols, they function in this session layer or the message layer. And you know what why these protocols are used? The protocols are used to help the user, or help the designer, help the developer to code the things to have the proper communication. And here comes the user layer or the user experience layer. This layer deals with providing the best experience to the end user of IoT products. To fulfill this layer takes care of the rich user interface, designs with lots of features. This is all about your application layer in the computer networks, or basically GUI based operations. How well you design their user interface, how well you present the user interface to make the system to make the system more efficient and easier to be used. And finally is the application layer. This layer talks about the application possible applications that can be built with the support of the rest of the layers. As you know, the OSI model, the 7 layers, here also the application layer that completely is handled by the user. So, and this application layer can deal with the application ranging from the smart city to the smart automation to the smart home to the smart industry, anything that can be used by this application layers. So I think with this, I conclude my lecture. Now we'll go back to the audience. If you have any queries, I can take the few queries and yeah. So now I'm back to.
Yes. Okay. Thank you very much,
Sir,
Professor
I hope
Chinara.
I haven't taken much time, right, sir? Did
Yes?
I take much time, sir?
No, no, no. It was a very useful experience.
Thank you so much, sir.
The IoT students should know. Actually, it is a today's technology, so they should know very well. And I think we have had the smart lecture from a smart professor from NIT,
Thank you so much. Thank you for
and
the compliment, sir.
everyone is enlightened with the um, lecture, and they have learned many things from this lecture. Now I'll request all the students, if anyone have any doubt, they can go and ask madam and get the answer. We'll allow 2 minutes, 3 minutes. After that, we'll conclude.
Sir, I can see a huge love in your institute. I mean, many students are there.
Yes. Yes, yes. We have made them sit in that lab, and they are taking the seminar over there.
Okay.
So that's a newly constructed lab
It's a beautiful one, sir.
since last 2 years. There are 65 computers.
Okay.
So any students?
So there are two possibilities. When the student don't ask the question, two possibilities. One is either they understood everything or they didn't understand anything. So
Actually, they have understood everything, as it is very spoken well from your side.
thank you, sir. But at least I'll be happy if I can get any query from the student side.
One or two questions should be there.
Yes, sir. One day, once upon a time, I was
I
in the
have.
other side.
Yes, yes. Actually, I have installed two Wi-Fi switches for my TV and my AC
So you are already in the
IoT
smart home, sir.
application. Because my son is there
Mm-hmm.
alone, always he stays alone. So I have installed these to check if the AC is running or if TV is running.
So you are already in the IoT ecosystem.
Yes, I am forced to be in the IoT
Yes,
league.
sir. That is the need of the time actually.
Okay. So I think there is no questions. We have understood everything from Dr. Chinara.
I have a question, sir.
You have a
Yeah.
question? Okay.
Uh,
Moktik, you can ask.
Good morning, ma'am, first of all.
Good morning.
So ma'am, what are the IoT, if we learn IoT, what are the future scope in IoT?
If you learn about IoT, very basically, I can say three things you can learn. Four things. One is sensing technology. Either you go for the hardware part, designing a sensor, how a sensor, again, designing a sensor has got multiple things: the size of the sensor, the material that has to be used for the sensor, the purpose of the sensor, where it is going to be embedded. So this is all sensing technology is one huge area. Another is the communication technology. So like if the sensing data is there, how it can be communicated, what are the protocols to be used for the communication. So like if I have some sensors here, I'm trying to communicate with another end, whether I should go for Bluetooth, whether I should go for the Zigbee, whether I should go for the Wi-Fi connection, what is the amount of data that is being sensed, and how fast the data can reach to the other end, that is also required. So considering all these requirements, I design the communication model. module. So that is one aspect. Third one is processing the data. When you go for the processing the data, you have to go through this machine learning thing, the data, all the data processing models, machine learning, deep learning, prediction algorithms, big data, cloud processing. Those things are also required that you can understand. And finally, the application side. How well you design a user interface so that the end user can use that. If I'm using a weather monitoring sensors, that means I should have an application which will show the weather forecasting, weather prediction, weather details, those kind of things. So if you say like if you study IoT, what are the things you can do? You have these four options. You can choose any of them because IoT itself is a huge area. It has got different sections and sub models. You can choose any of them. If you go more details about sensing, you are still in IoT. If you go more details in the communication, you are still in IoT. Or if you study about the artificial intelligence and these prediction things, analytics things, big data, you are still in IoT. So by any means, you are in this IoT umbrella. So you can, it is up to you whether you are interested for hardware, you are interested for user interface designing, you are interested for your software analysis part. You can, that is absolutely your choice. You can do that. There is a huge scope in this because it's not going to end at any point of time.
I think
Thank you.
properly explained, isn't it? Moktik?
Yes, sir. Yes, sir.
It is properly explained by Dr. Chinara, isn't it?
Yes, sir.
Okay. Acha, madam,
Sir.
we'd like to make a startup in IoT.
Sir.
So can you guide?
Of course, sir. Of course, if you are planning, we can work.
Startup Odisha has come up now in Bhubaneswar, O Hub. So we are going to visit that O Hub because they are having carnival for
Okay.
200 different institutions from 4th to 16th of this July. So we are visiting there. We'll get some idea from the policy and all that. Then after that, we are going to put some student on IoT startup.
Yeah, sure, sir, sure. That will be actually a great initiative if we can collaborate. I mean, NIT and B.O.S.E, Cuttack can collaborate and we can think of a startup because we have a startup center in NIT Rourkela, sir. We have a incubation center. So
okay, incubation.
Yes, sir. So we can easily do that, and government is encouraging for all those things. We can easily think of, and we can. I mean, you have good resources and use student strength. We have the student strength. We can use our expertise, and we can think of something really good, sir. We can do that.
I have already thought of one or two projects. I think that will be better to if we will collaborate and make this a prototype and
Definitely,
then go for.
sir. Definitely. Product oriented
thank you
things we can do, sir.
Okay. Thank you very much for your nice, smart lecture.
Thank you so much, sir.
So we will conclude here, madam.
So before I conclude, I'll just say one more line to all the students, especially.
Yes.
So if I get the permission.
Before that, I think, madam,
Sir.
before that, I think Mr. Soumya Ranjan, our senior lecturer,
Okay, sir.
he is going to.
Sure.
Good afternoon, madam.
Good afternoon, sir.
Madam, some students are queries that someone is making career in IoT-based company. Then how much package in annual and name of the best company, the IoT-based.
Sir, as I said, I know students will have definitely this query. This is a query that quite often it comes to the students' mind. There is no company like IoT based company. Whoever is doing that, they are a part of the IoT. Either, as I said, some companies they prepare the suppose let's say there are certain companies who are making the smart healthcare, right? So when they are working with the smart healthcare, they will hire some people, and when they hire the people, they will be asking as the smart healthcare has got some sensing part, some communicating part. As I said, it is always divided into four parts. So it is like sir, Aditya Birla is a company who is working on this smart healthcare. Suppose someone is hired in smart healthcare, that division, they will ask for whether you are good in sensing hardware, you are good in software or the machine learning things, or you are good in protocol designing or user interface designing. So depending on the skill of the student or the expertise of the student, they will allot him to one division. They cannot work on the whole of the IoT thing. It's not possible. When you go for this, job and all, they have to go for a specific thing. So the student has to be oriented from now onwards, whether they want to be in the hardware side or in the software side. Either they have to make themselves very strong in hardware fabrication of the sensors and then designing the sensor, then all those things, or they will good in the machine learning things, deep learning things, processing things, data analysis, those kind of things, or user interface designing things, or communication with the LoRa, the Bluetooth, those things. So they have to catch one of them, they have to be strong in one of them, but they should have the knowledge of the whole thing. They cannot say that I know only sensing part, I don't know the whole of this IoT part, but I know only how to work with a sensor. It doesn't work. When you are working with a sensor, you should know how the sensor is connected to a cloud, how the sensor is connected, is able to transfer the data to the server. So those things are required. So you have to understand the four modules thoroughly, but the one module has to be strengthened. You have to be very strong in one module, so that when you get the job, you can say that I can be a part of the IoT, but in this section. I can be in the hardware section, I can be in the software section, I can be in the user interface designing section. That is how you have to be, oriented.
Thank you, ma'am, for
I
your
think
valuable time to give our students. I think the student make career in this field. So it is a new technology in our systems. So most of the students maybe make a career in IoT base, because IoT base is a product based company. Yes or no, madam?
yes, sir. Yes, sir.
Yes. Then it is most important for all the students. Thank you, ma'am.
Thank you, sir. Thank you. So I have just one message for the students before I end my talk. Students, once upon a time, I was at your side. I was a student, and Devasis Nanda sir was my teacher at that time. So if I am here today, the major contribution goes to sir, because I learned the basics of coding from sir. He was so strong in coding at that time, and we learned Fortran, Pascal, basic. Though you don't know about all those things, but I did my coding from the Devasis sir. After such a long time, I see my teacher, and sir, heartfelt gratitudes and thanks to you. And
Namaskar.
because of your blessings and teaching, I am here today, sir. Thank you so much.
My
And I
my blessing will always be there with you.
thank you, sir. Thank you. Thank you
Okay.
so much. And students, all the best for your bright future. You can reach out to me anytime, and Devasi sir is there. So, sir, for any collaboration, anything, I am always there. We can do workout from our side, so there should not be any issue. And thank you to Samya sir and sir in the morning, Ramesh sir, probably Ramesh sir, right, sir? Ramesh
He's
sir.
from he has passed from NIT.
Yeah. I heard that. So by the time he entered NIT, he left NIT, I entered. So
Right.
somehow we could not